Welcome to Basic CNC G-Code Training. We're going to cover the fundamentals and building blocks for very basic G-Code programming. What we're going to use for our training format is going to be basic Haas G-Code. Most G-Code is fairly similar and can cross over to one another, but we're going to use the Haas format for our training videos here, which is actually very similar to Fanuc G-Code training as well. So, okay, to get started, the very first thing we're going to look at is the Cartesian coordinate system. So the Cartesian coordinate system is the starting blocks for G-code programming. We're looking at our machine from up above in the X and the Y axis for a milling machine. The very center of our Cartesian coordinate system is called the origin, or the x0, y0 start point. Looking at this Cartesian coordinate system, it's made up of 4 quadrants. The upper right quadrant, quadrant 1, all x numbers and y numbers will be positive. Quadrant 2, moving to the left, x will be negative, y will be positive. Quadrant 3, x will be negative, y will be negative, and then quadrant 4 in the lower right, x will be positive and y will be negative. Alright, when you look at this Cartesian coordinate system, the discriminant of each block can change depending on what you're programming. So most CNC machines, an inch will take a 4-place decimal. We're going to be programming everything right now to a 3-place decimal, so in the 1,000th scale. But looking at these blocks on this Cartesian coordinate system here, every block on this system is 1 inch. So we would be programming in 1-inch discriminants. We're going to be writing a sample program here in a minute. Alright, so now let's look at our first Cartesian coordinate system with points plotted out, and we're going to plot these points in an XY chart. So looking at this Cartesian coordinate system, we have a number of points on here, 8 points, and you'll notice that the scale is 1/4 inch scale. When we look at the first point, we notice it's 11 blocks to the right and 8 blocks up above the origin. So we would plot that first point as x of 2.75, y of 2.0. The next point we would plot as 1.75 in x, y of 0.5. Moving on to point 3, it is in quadrant 2, so my x is going to be negative, x of negative 1.25, y of positive 1.25. Point 4, x of negative 2.75, y of 1.5. Point 5, x of minus 2 inch, y of minus 0.5. We've moved down to quadrant 3, so x and y will both be negative. Point 6, x of minus 1.25, y of minus 2.25. Point 7, x of 1.75. We moved into quadrant 4, x becomes positive, y of minus 0.75. And then the final point, x of 1.75, y of minus 2.0. Now, if you were to enter these 8 coordinates, similar to what you see them, into a CNC machine, the machine is going to connect the dots. That's what a CNC machine does. You give it points and it follows the pattern of those points. That is the very basics of CNC G-code programming. Now we're going to move on to our first sample G-code program, and we're going to attempt to program this part. And what I like to normally do with my students is have them put a marker in the CNC machine, and after their program's done, go ahead and write this program out on a piece of paper using a marker in the spindle. So we're going to walk through this step by step together. So the first thing I like to do whenever I'm G-code programming always is to find my XY points. Now to the left I have my blueprint. We're going to spell out the words GRCC. It's going to be 20 points long. To the right I have my standard programming format sheet that I tend to always start with. You'll notice at the top there's the header of the program, in the middle is the XY points, and down at the end is the ending of the program. We are going to start right now doing what we know how to do, and that's just plotting our XY points. Then we'll get into the header, the ending, and the G-codes that go along with these points in the next step. Okay, so looking over to the chart on our left, the very first thing we have to look for is the XY0. And we notice that in our Cartesian coordinate system, the XY0 is to the lower left. That tells us that every one of these points on this graph are in quadrant 1, and they'll all be a positive number. So that makes it easy. So point number 1 is in the upper right part of the G. We're going to plot that point first. So if we count our blocks, again, we're on quarter-inch increments. We see that point number 1 is x of 1, y of 3. Now, if you need a copy of this CNC packet, it's very easy to create in an Excel spreadsheet. And then I brought this particular one over to Microsoft Word, but you can do this right in Excel as well. It works very well. Moving on to our next point, point number 2, x0, y of 3. Moving down to our third point, x0, y0. Then we have x of 1, y of 0. Point number 5, x of 1, y of 1.5, and point 6, x of 0.5, y of 1.5. So there's the 6 points on our G. So that's as far as we're going to program together, and the rest is going to be up to you guys to program. Now we're going to jump over into the G code, G and M codes, and the third category, letter codes, like I like to call them, to talk about some of the functions of the machine and how we can finish filling out this program. Okay, so what we're going to start with here are G codes. G codes are movement commands. You're telling the machine to move. So your first G code, the G00 at the top of the screen, is your rapid command. So rapid in a sense is telling your machine to move as fast as it can. Move at the maximum feed rate possible. So it's a linear move. So meaning one point to the next as fast as the machine can go. Typically when you want to use rapids is when you're approaching a part, when you're exiting or leaving the part. Anytime that you're not cutting the material, you want to be wrapping for the greatest efficiency. The next command, G01, is linear interpolation. So this is when you're feeding. So when you're actually cutting material and you want to control the feed rate exactly, you're going to use G01 feed rate. The rest of these feed commands, they get into drilling holes, cutting arcs, the different feed planes you're going to use. We'll talk about them as we go on in this course, but the very two that you need to know right now are going to be rapid and feed, G00 and G01. Now your M codes, the next portion of this, M code is machine functions. Okay, your G codes are going to be pretty standard across most machines, to where your M codes are going to be machine specific. So, and this is telling the machine to perform a function. So for example, M03 is spindle on clockwise. M05 is spindle off. M06 is going to be a tool change command. M08 is going to be coolant on. So with our M codes, we're going to tell the machine to perform a specific function, and usually that requires the machine turning a signal on or off inside the machine, like spindle on, spindle off, coolant on, coolant off, tool change. Some of the ones up at the top are pretty standard across all machines. When you get into air blast and pallet change and some of the unique functions that a machine can do, that's where you're going to see differences between your machine tools. And then our last set of commands are what I like to call the letter commands, and the letter commands are signal commands. You are sending a signal to the machine that says, hey, get ready to perform a movement, or get ready to record a number. So for example, your X, Y, and Z, which are your three primary coordinates, are letters. X axis, Y axis, Z axis. So by telling the machine, giving the machine an X, you didn't tell it to do anything. But if I give it an X command with a number associated with it, it's going to move to that coordinate. So these letter commands, they're communications. I'm communicating to a specific axis and telling it get ready to move. Or I'm communicating with my H to my height offset table. Or I'm giving it an M, which is your M code, telling it get ready to perform a machine function. So that's what we use these letter commands for. Now, getting back to our program, we have our XY points plotted for our G. Now, we're going to walk through this program from beginning to end and make it ready and readable for the machine. So, the very first thing you see in a G-code program, if you're on a computer, is the percent sign. So the percent sign you will not see inside the control. The percent sign is something you see on a computer. So this is an acknowledgement sign that for loading and or unloading out in or out of the machine through a USB stick or through a network. Here's the way you have to think of it. If you're on a computer, you have to have the percent sign. If you're just going up to a control and hand typing this program in, you do not need the percent sign. So it's just an acknowledgement command. Now the very next line is your program number. So that very first letter you see, that O, that is an O, not a 0. That's a common mistake people make. So it's an O, and then you need a 4 or 5 digit number depending on the age of your machine. So for this particular program, I'm going to give it a 5-digit number, O and a 5-digit number, 1, 2, 3, 4, 5. So that'll be my program number. Now on that same line, you're going to have your program name in parentheses. And it's very important that you put this number and this name on the same line, and the name is in parentheses. If you do it this way, then it'll actually show up in your program library as the program number and the program name. So inside my parentheses, I'm going to give it the name GRCC. The very next line would be our safe line or our setup line. Now this line is used to set your machine for the state you want to be when you're machining. So a machine has what's called a modal state, and your modal state is the command set in the parameters that the machine is upon power up, upon power off, upon anytime you hit reset, anytime you hit the program end, which is the M30 command. This is the state that the machine reverts to. So for example, we have G00, which is rapid feed, and we have G01, which is linear feed. You can only be in one or the other. You can't be in both at the same time. So which one of these is modal? Which one of these is the machine going to be in when you hit the reset button or end the program? So this safe line or setup line is how we're going to set the machine for this particular program. So for example, the very first code I see on there is a G00. So I'm telling this machine that when I start this program, I want the machine to be in a rapid state. G17, which is my XY working plane. So if I was to program any kind of arcs, it would program those arcs in an XY fashion. G90, which is absolute